Hello and welcome. In our lesson today, we are going to discuss extraction of lead metal from its ores. So lead has three main ores, and these are anglesite, cerussite, and lastly galena. Now galena is simply lead 2 sulfide and it's considered to be the main ore of lead. Extraction of lead occurs in three main steps. Step number 1 involves concentration of the ore. This is done through a process called froth flotation. Now in this process, what essentially happens is that as many of the impurities as possible are removed from the ore. In case you're interested in learning more about what happens during froth flotation, please check out my video on extraction of copper where I go into details about it. For the next step, reduction of the ore, and the last step involves purification of the ore through the electrolytic method. Now in the reduction of the ore, what happens initially is roasting. Now when we talk about roasting, we simply mean heating the ore at very high temperatures and in the presence of oxygen. So this usually occurs in a furnace. Now galena, which is lead 2 sulfide, is heated in the presence of oxygen. Now this leads to the formation of two products. We have lead 2 oxide and sulfur 4 oxide. Now sulfur 4 oxide is a pollutant, so that means that it cannot be allowed to escape into the surrounding. So essentially what happens is that it's either used in the manufacture of sulfuric acid through the contact process, or it's scrubbed. Scrubbing simply means a reaction of acidic gases like sulfur 4 oxide with calcium hydroxide. This leads to the formation of calcium sulfite. Now once the lead 2 oxide has been obtained from the roasting process, the next steps can then happen. So what happens next is that the oxide is combined with a few other materials, specifically with scrap iron, coke, which is essentially carbon, limestone, which is calcium carbonate. Now each of these materials serves a function of its own. So we are going to explain each in detail. Now let's start with the scrap iron. Now taking you back to the roasting process, the lead 2 sulfide was reacted with oxygen in order to form lead 2 oxide. But you'll find that not all of the lead 2 sulfide reacted with the oxygen. Some of it remained unreacted. So the purpose of adding scrap iron is simply to reduce any unreacted lead 2 sulfide to lead metal. Just a reminder, iron is more reactive than lead. Therefore, it displaces lead, combines with the sulfur to form iron 2 sulfide. Lead is then just deposited, or it just remains uncombined. So at this point, let us just assume that all the lead 2 sulfide has either been reduced to lead metal or it has formed lead 2 oxide. Now let us proceed to the remaining two materials. Coke acts as a reducing agent. So it reduces the lead 2 oxide into lead metal. So this is the reaction. Lead 2 oxide is reduced by coke, which is carbon, to form lead metal plus carbon 2 oxide. Now just a note, carbon 2 oxide is also an excellent reducing agent. So what happens is that when carbon 2 oxide is produced, it also reduces the lead 2 oxide that is present. So this is for the reaction, this is for that reaction. Lead 2 oxide is reduced by carbon 2 oxide to form lead metal plus carbon 4 oxide. So by this point, we should expect that all of the lead oxide, all of the lead 2 oxide has been reduced to lead metal. Now on to the last one, which is limestone. So limestone is simply calcium carbonate. On heating, calcium carbonate decomposes to form calcium oxide and carbon 4 oxide. Now what is required from this is actually the calcium oxide. Now let me tell you why. A lot of the ores tend to have silica as one of the impurities. Silica is simply silicon 4 oxide. So in order to get rid of the silica, what happens is that calcium oxide needs to be present. Now silica is an acidic oxide. Calcium oxide is a basic oxide. So these two easily react with one another. So calcium oxide reacts with silica to form calcium silicate. I'll write the equation over here because I find it to be a little bit crowded. So let us have our calcium oxide. And then over here, let us have our silica. So silica is silicon 4 oxide. So it has the following chemical equation. Now, onto the calcium silicate. Now, it's very easy to know how to write calcium silicate if you know the chemical formula for these two compounds. So calcium silicate simply contains whatever is present here. So we have calcium, silica, and then lastly oxygen. 2, 3. So just the way they are, you transfer them the way they are. Now this is referred to as slagged. So what happens is that it's simply tapped off and removed as waste. Now we are done with the second step, which is reduction. So at this point we have lead, but the lead that is present is not pure. Now in order to ensure that it's pure, the next step needs to happen, which is electrolysis. Okay, now for the electrolytic process. So the electrolyte that is used is any solution that contains lead-2 ions. Now it could be a solution such as lead-2 nitrate as long as it contains lead-2 ions. Now the anode that is used is the impure lead metal that is obtained from the above extraction process. As for the cathode, pure lead metal is used. Now at the anode is where oxidation takes place. And remember, oxidation refers to the loss of electrons. So that means that lead atoms present in the impure lead are going to lose electrons and go into the solution as ions. So every lead atom is going to lose 2 electrons in order to form lead-2 ions. So you'll note that over time, what happens is that the anode decreases in size. And this is because the impure lead metal undergoes oxidation, losing electrons in order to form lead-2 ions. And this is as intended. Remember, the goal for electrolysis is simply to ensure that the metal that was obtained during the extraction process is pure. Now, at the cathode, what happens is reduction. This involves gaining of electrons. So lead-2 ions in the solution are going to gain 2 electrons each and be deposited on the cathode as pure lead metal. So over time, you'll note that the pure lead rod, which is the cathode, increases in size. And that, ladies and gentlemen, brings us to the end of our lesson on extraction of lead metal. Remember, if you want to test your understanding of this process, you can simply tune in to my video where I tackle past KCSE questions on extraction of lead metal. See you there.